Hello, everyone, and welcome to Historical Geology 1404. I am your substitute teacher for the day, Jack Sparrow. Captain, Jack Sparrow. I have my jar of dirt. Can't have any Krakens coming in here after us, can we? All right, happy Halloween. It's not often that class lands on a Halloween day, so when it does, I eat it up. Kudos to the rest of y'all that are dressed up. Love the face paint, Jocelyn. No? That you did that in 10 minutes? Well done. Well done. All right. Today is your Exam 1 review day. Yay! It's Exam 1 review. Exam 1 opens after our class session today. Yes.
So it opens after today.
It opens today.
Yes. When will it close?
It'll close. I think I have it set to close on Friday, but I'll double check that here in a minute. Here, I might as well double check it now. So let me give you some information. Nope. Here we go. Yes, I have it closing on Friday, tomorrow at 5 p.m. Yep, so you'll have more than 24 hours to take it. There should be plenty of time.
Yeah.
There's no school tomorrow for you. For those of you in high school, I'm assuming.
Yeah.
Okay. Well, that's convenient. Plenty of time to take the exam then, right?
Exactly. Just gotta not forget.
Yeah, just don't forget. Exactly. All right. Some information about your exam. It is 20 questions, all from Module 1. You have the normal extended time limit, 500 minutes. It's all the usual suspects, multiple choice, short answer, yada, yada. There are going to be a few photos on there. Hopefully, your computers, if you're using ECISD laptops, do not give you a hard time. I strongly encourage you to try and take this exam using a non-ECISD laptop, because sometimes the firewalls block the pictures. And then, oh well, I don't know what we can do about that, right? Huh? You have to take it on your phones? I mean, you can take it on your phone. That's fine. If you can open. Can you open Blackboard exams on your phone? Interesting. I've never tried. Nice. Okay. Good deal. Well, that's an alternative then. Just remember that if you open your exam on your laptop, realize, oh, wait, I can't see these pictures, and then try opening it again on your phone, it will probably auto-submit for you because you only get the one submission. Okay? So make the choice early. Am I going to roll the dice and expect that I can use it on an ECISD laptop, or am I going to try it on a phone or a personal computer instead? Okay? What else? I think that's all of the general information about the exam for you. At this point, we will turn to questions. Now, I don't believe that I got any questions from the online students, but let me just double check here. No, I got no questions from any online students. So, the show is yours, my friends. Yes?
Uniformitarianism.
Uniformitarianism.
And will you be using like the extended definition that we talked about last time?
So if I ask you what the principle of uniformitarianism, you're asking if it's going to be that basic short version or the long version that we keep adding to. The long version is probably a safe bet. I would accept the short version, but we know more about it now, right? It's not simply that we can use the present to interpret the past. Now we know we can use it to interpret the future and other worlds, right?
Yeah.
It's extended beyond that.
And can you like, let's say it verbatim?
Yeah. The principle of uniformitarianism is any physical, chemical, and biological process that occurs today also occurred in the geologic past. And then adding to that, will occur in the geologic future. And then adding some more, and occurs on every other world. Now, there's some variation to that last part, okay? Rocky planets like Earth are going to behave in very similar manners. But a gas giant like Jupiter or Saturn or Uranus or Neptune, those are made out of a different composition. Physics still works on them the same way. They still have hemispheres. They still have giant storms. They have atmospheres that are subject to physics and chemistry the same way they are here on Earth. So while those physics and chemical processes are going to be the same, I wouldn't expect you to be able to go to Saturn and be able to say geologic process. For all we know, there is no geologic process on Earth, on Saturn, right? Theoretically speaking, all those gas giants have, and it's not so much theory anymore, it's scientifically agreed, we just can't see them, that they have a solid inner core, and they are surrounded by all those gases. What those solid cores are made out of is anyone's guess, really, though, because we can't see them, and we cannot build a probe that will go down into them because of the incredible pressures from the gas clouds surrounding that core. Any probe we send in would be destroyed.
Thank you.
Of course. What else?
Are we going to have to be identifying minerals and rocks?
No, there won't be any sample identification here. I do reserve the right to show you a picture of something and say, based upon what we learned in class, what do you think this is? We did some of that, right? But there won't be a, here is a video, collect the properties, tell me what it is. Yeah.
Will there be a question that says, judged on this rock, build its environments?
Potentially so, yeah. So especially in the last few lectures, we've discussed using our knowledge of minerals and rocks and structures to reconstruct the environments that those occurred in, right? That they were formed in. It is very possible that I could reference that sort of thing on this exam. Remember, we've only covered 4 lectures worth of material that's going to be on this exam, right? So just based off of that, it's a pretty safe bet that we'll touch on just about everything we talked about. 20 questions, that covers 4 lectures. Yeah.
We have something in the class that covers like basically lab 2.
The stratigraphy, I won't give you a stratigraphy thing to fill out. It's possible I could give you one to partially interpret.
What was it called? The volcanoes that go up and then a lake, a lagoon from.
Yeah, so when a volcano forms in the ocean and it grows up above the ocean surface, a coral reef starts growing around its outside perimeter. And then the volcano dies, it gets weathered and broken down. Its material is reduced all the way down to sea level. But that ring of coral reef is still there. We call that an atoll. A-T-O-L-L. Atoll.
And the inside is the lagoon, right?
Yes, and the inside of this atoll is a lagoon. It's not the only place we can find a lagoon. Anyone remember the other circumstance that we learned about where lagoons can form?
Behind the barrier island?
Yeah, exactly. Behind barrier islands. Well done. Are you wearing a Kevlar vest too, Cade? Are you wearing a Kevlar vest too? You're fully decked out for SWAT, aren't you?
With the Hello Kitty.
Yeah.
Hello Kitty on it.
Yeah.
Deadly. Deadly.
Yeah, I'd be scared of that SWAT guy. He's man enough to wear Hello Kitty on his Kevlar. All right, yes.
So the main difference between marine and non-marine environments is the ocean.
Yes, marine environments are any environment that are within the bounds of the ocean. Non-marine is everywhere else. Even if it's a lake or a river, any freshwater body, it is still non-marine.
What are those structures that form the deserts again? Are they like, what is it, like lean beans or something like that?
Yardangs?
Gardens.
A yardang forms when you have some geologic feature, an outcrop of some kind, that is weathered faster at the bottom than it is at the top, and it makes that mushroom shape. Why does it get weathered faster at the bottom than the top? What do y'all think?
Because I think of all like the direct dust a lot and it's like the bottom.
Yeah, so what's getting pushed along the surface?
The heavier thing?
Yeah, the heavier things like sand. The smaller particles get picked up by the wind, silts and clays. Those are not carrying as much energy. They don't have as much mass, and so they won't weather the top of your formation as fast as the larger sediments like sand that are getting blown across the ground level. Okay? So weathering faster at the bottom means you get that mushroom sort of shape that we see in yardangs.
But this one we have like questions about structures in that as well.
Yeah, structures are fair game. Anything that we talked about in the last 4 lectures, fair game. Yeah.
What are the different types of dunes?
The different types of dunes. So you've got your Barken dunes, which are those crescent-shaped ones, right? Then you've got transverse dunes, which are the ones that you get in places with lots of sand. We call them sand seas, right? They kind of look like waves in the ocean. You've got star dunes, which are multiple dunes that meet together depending on changes in wind direction. So if you get wind one direction in the morning and wind another direction at night, you might get some star dunes forming. Then there are longitudinal dunes, which are an elongated shape. If you have a stronger wind, it kind of takes your Barken dune and stretches it out. You've got what I say? That name is escaping me. I had a long night last night. I was up all night with my kids. They weren't feeling very well. Let's see.
You gonna trick or treat with them?
I won't be able to. I'm in rehearsal all evening, but my wife will take them trick-or-treating, yeah.
What?
Rehearsal
Oh,
at the Globe?
Are you like that the entire time?
No. No, I'll be wearing my actual costume for the play. We open in 9 days.
you should have wear it right now, like for today.
My costume for the play? I don't have it. No, our costume director has that.
You should have.
She, it's the Lady of Shalott. So it's a King Arthur story, the Knights of the Round Table.
So you just got in 9 days to go.
Yep. Yep. And students get in free with their ID. Just letting you know.
I'm going. We're going.
You
Don't worry
going?
about it, don't worry.
Nice. Just don't heckle me. But even if you do, I won't acknowledge it. All right. What else?
So an abrasion is when uh, the glacier, like the size, scratch the size.
Yep. Abrasion, glacial abrasion is when your glacier is scraping material off of a surface. So it could be the sides, it could be the bottom of your valley, whatever it's doing. It is abrading all that material away. Which is why when you go to places like Ohio, it's tough to find any rock on the surface that's younger than 300 million years old. For sure, there was rock younger than that a while ago, but repeated glacial cycles have scraped all the younger stuff away.
What are the different types of glacial landforms?
Well, there are a couple. The arêtes are what we call those ridges between the glacial valleys, right? The horns are where multiple arêtes come and join together and make a sort of peak. Roches montagnaises, that's when a hill has the misfortune of being in the way of a glacier, and one side of it gets scraped flat into a wedge. Fjords are what happen when glacial valleys get flooded by the ocean after the glacial sequence has ended. Glacial scars are the grooves that we see in rock if a glacier has kind of dragged a rock across other rock and it kind of digs its way into the rock that's on the bottom. Kind of like if I had, let's make this a seasonal example. If I had a pumpkin pie in front of me, right? And I took it's always food. It's, hey, who can't relate with food, right? And I took a graham cracker crumb and I just a piece of graham cracker and I put it on top of that pumpkin pie. And then I used my hand, and while I never touched the pumpkin pie myself, I kind of dragged that graham cracker across the pumpkin pie. It would leave a groove in it, right? And yeah, the graham cracker is also kind of soft. It would probably fall apart as it went, but it would still leave a groove behind. That's what those glacial scars or glacial striations are. Angel, did you have a question a minute ago? No?
Mount Roche-Montagne leaves like some sort of material. What is that material?
A roche montagne? There's not a particular material that's left behind on a roche montagne. The material that glaciers leave behind, we call that till. Is that what you're thinking about?
Probably.
Yeah, that crushed pulverized rock is called till. And when it gets compressed and lithified, it becomes the rock tillite.
Like with the rocks from these different types of things operating effects.
Potentially so. Not in the form of, again, not in the form of identify these, but perhaps in the form of these rocks tell you what about the environment. That's what the big theme was for Module 1. Using what you learned in 1403 to interpret environments. Module 2 is going to be life, how it develops, how it began, how it changes, all of that in those environments. And then in Module 3, we're going to talk about the geologic history of Earth. We're going to go over all the time periods and tie it all together because you learned about environments and you learned about history of life. And now we're going to go through the whole sequence of all of these things happening on Earth in Module 3. Okay? So it's all tied together. It's all relevant.
So are we also going to see like different types of bedding systems? Like
Bedding could be referenced for sure. Bedding being where two layers of rock are distinct from each other. So I would say bed A, bed B. Well, how do I know that they're separate? There is some difference between the two such that I can see a bedding plane between them, right? Perhaps two different sequences of deposition. Perhaps they're both sandstones, but one has a significantly smaller grain size than the other. It'll be obvious, right?
What is glacial more
Moraine.
moraine?
Glacial moraines are the conveyor belt trackways of debris being carried downhill by the glaciers. So the three that I taught you about, you've got your lateral moraines, which are on the sides of your glacier. As material is being scraped off the sides of your glacier, it collects on the sides of the glacier and gets carried downhill in those lateral moraines on the sides. Where two glaciers meet up, where their valleys converge, the two lateral moraines that share that junction combine and make a medial moraine in the middle of what is now a larger glacier. Okay, that's the medial moraine. And then at the base, wherever your glacier is currently melting and dumping all that sediment from the lateral and medial moraines, it makes a pile of sediment that we call a terminal moraine.
This is like glaciers hitting each other.
Glaciers hitting each other?
Yeah.
Yeah, when they converge and they make a larger glacier.
They always hit that, or do they like change the directions as well?
They don't really change directions. They follow the path of the original low point. So normally a glacial valley will develop when ice starts flowing down where water flowed before. So if you have a high mountain stream and that mountain grows up high enough that now that stream is above the snow line, any ice that compacts up in that area will flow naturally down the path of least resistance, right? That's the way gravity works. It forces things down the path of least resistance. And so that stream bed will now become a glacial valley. So wherever that stream bed was flowing before, that's going to be the path that the glacier takes, at least to begin with. It can plow its way through and widen that valley out as time goes on, but the initial path will follow that whatever feature was there before.
A glacier is like a big ice, right?
Yep. Lots of ice. Hundreds to thousands of feet of ice.
I'm just gonna go over like how like soil gets used up. I forgot what it's called.
Soil will definitely be a possibility to be referenced. I didn't spend too much time on soil in our little review of this module, but I do expect you to remember what the different horizons represent, what soil is and how it is formed, things like that.
Can you go over the different horizons?
Yeah, you've got your O horizon. Say it louder, Jocelyn. The A horizon. What's the O horizon made of? Before we go there, what's the O horizon? Huh? Organic material, mostly organic material, right? Decaying vegetation, dead squirrels, stuff like that, right? Mushrooms. And then your A horizon, right? Exactly. What's your A horizon got in it?
Minerals?
Huh?
Minerals?
Mineral content, yep.
And the stuff is mostly soil.
Right, exactly. The O and A together are what we call topsoil, but the A horizon itself is the best. Some plants will thrive better on organic rich soil, like in the Amazon. Thrives. All those plants have adapted to thrive on organic rich soil. Minimal mineral content, high organic content. Most soils, though, that A horizon, that's ideal because it's got that delicate balance we talked about before. Then what do we got? The what? Okay, the E horizon. The zone of alluviation, right? Often it's a lighter color. When I was doing some soil sampling in Ohio, there are places over there that have just the most perfect E horizon that you can imagine. It's like totally bleached white. So you chop down, we did cross sections of like 6 feet down into the soil. And a couple of feet down, you just get this bleached white layer. Classic E horizon. Okay. What's beneath that?
Your B horizon?
B. Yep. That's where all of your clay-sized particles go. And when it gets compacted, it becomes water resistant, right? And then underneath of that is your unconsolidated material, your weathering parent rock, right? Okay.
So if you have questions more for like things we focus on, like actually focus on per se, so not as much of a possible for like let's say like maybe like one or two questions on that.
I'm not going to tell you how many questions would be on which
No,
subject.
Based on like what should we like focus on more, like things that we dealt with.
Yeah, what should you focus on more? I'd say you should focus mostly on lecture 1, 2, 3, and 4. I'm getting deja vu. Yeah.
So far.
Huh? I am a pretty funny guy.
Yeah, who told you? I tell you.
Only people I pay tell me I'm funny. No. No. Claudia and Zara, how you feeling about the exam? Nice. Confident? I love it.
It is. This one's gonna be a.
Yeah, I mean this one I think I'm pretty safe in saying I am confident in saying it will be a pretty easy exam for y'all. Yeah, it's a review of things that you've already been tested for, right?
Yeah, like we've already seen this stuff.
Yeah. I'd say only about maybe 10 to 15% of anything we talked about in the last few weeks is new material. The rest of it is just 1403 stuff.
Thank you.
Yeah. Next week, we're going to start on brand new stuff. Yeah, it's going to be fun. Module 2 is probably my favorite module in this class. Yeah.
How long is that?
2 more weeks, 4 lectures, and then another exam. And then,
These models are like short.
huh?
They're shorter. Like last, the other classes were like 8.
Yeah, it's inverted from 1403. So for 1403, the first module took 4 weeks, and then there were 2 2-week modules after that. In 1404, in this class, there's a 2-week module, a 2-week module, and then a 4-week module. Because there's so many geologic time periods, we take 4 weeks to cover them all and tie it all together. So it's inverted from 1403. But you will have a cumulative final exam after that. You also do have a lab exam, but you'll get that probably end of week 7. I usually give you the lab exam for 1404 the last time we meet before the final exam, because you don't have all the information that you need to complete the lab exam until you've had the last lecture. Now, we do have a day off in November, because it just so happens we meet on Tuesdays and Thursdays. And there is a Thursday happening on a little day called Thanksgiving, right? So Thanksgiving break at OC starts on Wednesday, the day before Thanksgiving. So we will meet on Tuesday that week, but then we have Wednesday, Thursday, Friday off.
Are you gonna bring Christmas present?
Am I going to bring you a Christmas present?
On Thanksgiving?
Hold on, my laptop just turned off.
Or yeah, Christmas present to say thank you.
To say thank you to you?
Mhm.
Probably not, but thanks for asking.
I think it's gonna be November.
Yeah, we end, I believe December 10th is the last day of the semester. So it'll be a ways before Christmas. I am going caving the day after Thanksgiving. I usually do every year.
I've heard about that.
You heard about that?
Yeah, some friends with Soraya.
Ah, yes, Soraya told you. Yeah, she might be coming with me on this trip. We'll see. There's a bunch of people over in our cast for the play that they want to go with me on this trip for Thanksgiving. We'll see.
They sound fun, to be fair. Like,
It is fun. It's really fun.
We should
It's
go
dangerous.
mining.
Mining?
Yeah,
Done that.
Huh?
I've done that.
we should go like to see if we found like something good, you know.
Something valuable around here?
I don't think it's much fun.
Nope.
What
The only mineral value that we have around here, mineral in the definition of the mining term, right, is oil.
I don't know, you might want to check it a little bit, you know.
Huh?
You might want to check it a little bit.
Yeah.
What is it that you did that you said like you made like a river to find the minerals, like with something that you drill and then you like follow a path.
Yeah, hydrothermal deposits. So what happens is a magma chamber underground is cooling off. And as it is cooling off, this is at the very end stage of it cooling off, right? Groundwater interacts with it. And that groundwater gets really hot, but there's not enough space for it to turn into steam. So it's just really hot water. And it dissolves metals out of the newly forming minerals, or out of the newly forming, the minerals, right? So things like gold and silver and copper and platinum and lithium, okay? All these metals get dissolved out by the super hot water and get carried further and further away from this magma chamber as groundwater continues to push down towards zones of lesser pressure, right? So at the gold mine, me and my team, we would find these old magma chambers underground. The ones we worked with were Jurassic aged. And we would say, okay, it's surrounded by sandstone, or it's surrounded by a conglomerate, or, we'd figure out what kind of rock was around it. And then we would drill all around this magma chamber until we found the direction that the gold-bearing water flowed away in. And we figure that out by, we'd take a sample here and a sample here and a sample here and a sample here all the way around. And then whichever drill holes came up with the most trace amounts of gold, we were like, okay, groundwater flowed away in that direction from the magma chamber. And then we would just keep drilling off in that direction, following the path that groundwater took. Anytime that we found rock that had enough gold in it, we'd make a mark there, and then the mine would be able to open a new pit there. Ideally, what you want to find is a location where the gold reprecipitated, so where it reformed out of the water, and then you have a very rich deposit of gold right there. That's the goal.
Do you have you keep that gold that you found? They don't allow it?
You don't really find gold like in nuggets anymore. That's what we call a placer deposit, when you just find a nugget of gold sitting on the surface. Most of those have been pretty well tapped out. That's what all the gold rushes did. They found most of those places and stripped off all the gold from the surface. Huh? I'll find a piece. I do have a piece in my office, but it's from Alaska, and I didn't find it. Someone else did. Most of the time, what we're working with on a gold mine is pit mining. So you're basically digging up hundreds of thousands of tons of rock, and you dump it in a pile. This is rock that we call ore. Ore is just rock that is rich in a certain resource, right? So you take all this rock that is rich in gold, you dump it in a pile, and then you put chemicals all over it that are designed to strip away, to remove the gold from that ore. So in the case of gold mining, we use something called cyanide leaching. So you have a cyanide solution, which, yes, is very poisonous, right? Our pools of cyanide solution, we had to put nets over them to keep birds from landing on them and dying, because it looks like water. So birds would just fly over and land in it and die. So we had to stretch nets over our pools of cyanide solution. But there are hoses that go from these pools of solution, and we stretch tubes, pipes. Okay, we stretch these rubber pipes across acres and acres of this ore that's been dumped. It usually takes months, a couple of months to maybe 6 months to get a pile of ore that is a couple of acres wide in each direction and then maybe 100 feet tall. Okay, we make a huge pile and then we stretch all of this tubing across it, and then we start dripping cyanide solution through that. And after about 6 months, we start seeing gold bearing cyanide solution come out the bottom. It takes a long time for this to happen because there's a lot of rock that cyanide has to go through. But when it does, it's bearing a lot of that gold. And then we simply collect it in tubes at the bottom of the pile. And then we pass that gold-rich cyanide solution through carbon, just pure carbon, that black, dusty stuff that you see in like carbon pills, if you've ever taken those or anything like that. It's just carbon. And the gold attaches itself to the carbon. It says goodbye cyanide, attaches itself to the carbon. And then that's what we take. We call that a slag. Okay, so it's just really dense, heavy, black. You would think it's garbage just by looking at it, right? Almost kind of looks like dried poop. Yeah, it's gross. It does not look like it's worth anything. But then we take that and we throw it in a smelter and it melts out the gold. And then that's where we make our gold bars from. But silver comes out through the same process. Silver is extracted by the cyanide. Silver is attached to the carbon. And so we don't get pure gold bars out of this process. We get what we call doré, D-O-R-E. Doré is just a bar of gold and silver alloy. Okay, it's about 12% silver and the rest is gold, typically, at least at the mine I worked at. Okay, that was the difference there. Sometimes a little copper and a few other traces, but it's mostly gold and silver. And that's what we would sell to a mint. And the mints are where this metal goes to get turned into coins. So we would sell our bars of gold or of a doré to the mint, and then the mint would melt them down and remove the silver and everything else and all of that. Go about what they wanted, whatever they wanted with it. At the time I worked at the mine, each bar of doré was worth maybe $500,000 to $750,000. And we would ship out maybe 7 or 8 a week, I think. Yep.
Should have kept one.
Right, because I definitely wouldn't be in prison right now if I had tried taking one.
I don't think you
Yeah?
would be retired by now.
Yeah? Bar of doré about that long and about that wide is about 50 pounds, brother.
Uh-huh.
How are you going to hide that?
In the pocket.
Just in your hoodie? Like,
Uh-huh.
it's like your hoodie sagging in the front in the shape of a bar and no one's going to check you. Right? You just shove it in your backpack and then it just like falls out the bottom of your backpack because it's so dense.
Honestly.
You would?
I would be retired by now. I would take the risk.
You'd be retired in a nice 4x4 cell.
Let's be generous. Let's give them 5.
No, they are very, very, security is huge at gold mines. Everything is kept behind a massive safe. I only saw the inside of the safe once, and that was while there were about a dozen security guards.
I'm going to
I could do it.
Yeah? All right, Angel. I'll look for you in the funny papers. Okay. What else?
I don't know if we got no more questions.
Nothing? All right. Everyone look at me. Are you ready for the exam? There's nothing you want to ask about. You have no doubts about any of these subjects.
Pretty confident.
All righty. Well, in that case, we've been going for 40 minutes. I'm going to go ahead and end the recording here and open the exam.